Ever wondered why your server crash exactly when the traffic spikes? Why websites fail during sales or API died during peak hours? So for example, let's say you have got your application and everything is working normal. And suddenly, let's say if it is handling 10 users, at the same time it is working fine. But let's say your application is an e-commerce website or an e-commerce application and suddenly there is a time of sale. And at the sale at the same time 10,000 users logs into your server and the result is this server crashes, right? So today I'll explain you in the simplest way possible using a restaurant example that why server crashes under load. So hi everyone, my name is Ashish and today we are breaking down one of the most misunderstood concepts in tech, why servers actually fail under load. So this video is the part one, the theory. In the part two, I'll show you a live demonstration on EC2, Docker, and some load testing tools. So let us begin, and we will understand this particular analogy using a small example of a restaurant. So imagine you own a small restaurant. So this is your restaurant, and at first 10 customers walk in. So for example, this is this 10 users or customers that walk inside your restaurant. So everything runs smoothly. You are able to cater all the requests by the customer, whatever food they want to order, whatever drinks they want to order. So everything is running smooth. Now suddenly your restaurant becomes famous. Now first 100 customers come. So initially you were handling 10 customers, everything was fine. Now you are handling 100 customers. So 100 customers are posting a request to your restaurant. So then you will face a little problem. Now let's say that your restaurant becomes viral and now 1,000 customers come into your restaurant and order food. So what happens? So you have got certain limitations with your restaurant, right? So first limitation is the kitchen staff is limited. Kitchen staff is limited. Then inside your restaurant, you have got a fixed number of tables. Fixed number of tables inside your restaurant. And third is with the limited number of staff, your cooking speed is limited. So naturally, what will happen? So with all these resources and the request that you have got, so naturally there are going to be certain consequences. So what are the consequences that the user will face? First is like the orders will get delayed. Orders delayed. Second, the problem could be, customers may get angry because their orders are not being catered. So the customers get angry. Then some of the customers may also leave since their request is not catered. So some of the customers may also leave. And third is your kitchen is also overwhelmed. Like you have a lot of work. Kitchen is overwhelmed. So how this analogy helps us understand why server crashes? So we'll map it accordingly. So on the kitchen side, let's say this be your restaurant. So this is your restaurant, right? So restaurant has got what? So restaurant has got first. First is the customers that you have got. First dependency is customers. So when you are hosting an application, you have got customers in the restaurant, and let's say this is your application or server. So inside the restaurant, the customers are there, but inside your application or server, you have got users. Then inside the restaurant, you have also got what? You have got orders. Who places the orders? Customer places the order. Similarly, inside this, your server, you get requests. So here you have got request. So who places the request? The users places the request, just like the customer places the order. Third is you have got a kitchen. So restaurant has also got kitchen where the food is prepared. And the application or the server where it is hosted, it has got the server itself, that is the kitchen. Then in your restaurant, you have got staff who manages everything. So you have got staff in the restaurant. Wherein inside the server, what do you have got as an alternative of staff? You have got CPU that does all the processing. And one more important thing that you have got in restaurant is your storage, where you're storing your foods and where there are tables where people sit. And just like inside the application or the server, you have got RAM. So this is the analogy. Just like with multiple requests, the restaurant cannot, cater all the requests, and as a result of which users get dissatisfied, they walk away, they are angry. Just the same way, when there is a server in which our application is hosted, and if the server is not able to cater all the requests, people tend to leave and the server crashes. So this is an analogy. So for example, customer over here is equivalent to our users. Then the orders that the customer places is equivalent to the request that is made by the users. Then the kitchen over here where the food is prepared is equivalent to the server where actually the application is hosted. Then as compared to uh, you know the RAM that you have got here in the app server, let us name it 4. You have got storage and tablets over here. And fifth, who does all the processing inside the restaurant is the staff, just the way CPU does all the processing over here. So this is a simple analogy in which we can understand that why a kitchen fails when there is, way more, people who want to go inside that restaurant, and the restaurant does not cater that. Similarly, when there is a server and there is way more requests than they are anticipating, then the server also crashes, right? So then there is a question that how to choose the server size. That's a very important question. So server size is, the first point that we have to cater is like estimate users. So for example, just like in restaurant, if you are opening a restaurant in a remote location, then you are very much aware that not much people are going to come inside the restaurant. But if you are opening that restaurant in a very busy center of the city, you are very likely to attract a lot of customers. So this applies to servers as well. So what does it apply over here? So in the case of servers, whenever we are choosing a server size, we have to choose that how many users are we going to cater. If there are 100 users, then we can do the work with a small server. And if there are more users, let's say there are 10,000 users, then we need a bigger server, comparatively bigger server. And if the number of users are way beyond 10,000, let's say 10 lakh users, sorry, 1 lakh users, then we may use a distributed system. That means bunch of servers that are working behind to cater the request. So server capacity also depends upon the expected load, not guesswork. We have to understand that what kind of users are we going to cater and how many users are we going to cater. Now let's move on to type of application. So first type of application that we can understand over here goes to, let's say if it is a app, static application or a website. What is a static application or website? So these are basically your HTML and CSS pages. So server barely does any work. So CPU load is very minimal. So if it is a static application, then you use a low CPU. The server requirement is low CPU, not much task to do. Wherein if it is a API backend, so API processes basically logic, queries, validation. So you need comparatively more CPU than that of static sites. So here you need a medium CPU because a lot of processing work is supposed to be done. So here you're using a medium CPU. Now third could be, let's say if you are using a video streaming application, video streaming. So in video streaming, streaming requires a lot of encoding, sending large video files continuously. So CPU and network bandwidth both must be high. So here you need an extremely high CPU, right? So these are some of the basic use cases, like what kind of application. And one more that I can think of is, let's say, machine learning, which is very trending right now. So if your application does work on machine learning, so machine learning, so these workloads basically involve mathematical operations. So this eats CPU like crazy. So here you require a extremely high CPU, right? Fair enough. So this is what I mean by type of application. So first we also understood that estimated users, how many users is my application going to cater? That also helps us while considering the server size. Second is the type of application. Now third, let us understand the request type. So what could be the request type over here? Let us understand over here. So request type could be, for example, if it is a light request, that means what? You require a low CPU and low RAM. That means the request is not very often. So that's why you require low CPU, low RAM. So what these tasks could be? This task could be simply fetching data or static files like the one I discussed. So simply fetching data or static files. That is one kind of a request. Second, first one is the light request, and second what we can think of is a heavy task. Two tasks, right? So what could be the heavy task? So heavy task would require us a high CPU and high RAM. So what these tasks could be? So anything that involves, let's say, big calculation. Then it could be uh, image or video processing, or maybe some, large DB operations. So here the request type is also very important while considering what kind of server do we have to choose. Moving on to the fourth, point while we have to consider while choosing a server is like load planning. So we have to always ask, what if, like while we are provisioning a server, let's say we have chose a server of XYZ configuration, we have to always ask a question, what if traffic suddenly spikes? What if traffic suddenly spikes, right? So this is where like most of the servers crash. So most servers don't crash in normal load, but they crash when the traffic suddenly jumps. So for example, your server is good to cater 100 requests, but suddenly 10,000 requests comes in. So that is where your server won't be able to cater all those requests, and it went to and it goes to a crash situation. So you must plan for the worst moment, not for the average moment. So here are the four considerations that we have to keep in mind while choosing a server. So estimate users, how many user is my application going to cater? The type of application, what kind of application am I going to deploy on that server? Is it going to be a static application, an API backend application, some application that does a lot of video streaming, or maybe a machine learning application? So likewise, the server parameters or requirements is going to be different. So what will server parameters or requirement? Just understand this analogy. So customers more, then there will be more orders. Similarly, if users are more, then there will be more requests. And if more requests are there, then we'll be using, a bigger kitchen over here. That means a bigger server for hosting your application. Then, to manage your particular restaurant, you have got to have more staffs. Likewise, you need to have more RAM, more CPU, and for storage, you need to have more RAM, right? So these are the parameters that needs to be considered while choosing a server for your application. Now we have to understand, okay, let's say we have, provision our server over here. Now we also need to understand that how to check the server performance. Like if my server is there and if application is deployed, users are accessing the application, so how is it deploying? So we also have to have certain metrics, key metrics that I should know. For example, if it is a CPU, I should know that if the CPU utilization is between 0 to 50%, it is safe. I can call it to be safe because 0 to 50% the CPU is working in a very nominal mode. It is, doing the basic firefighting and does all the job efficiently. But if the CPU utilization spikes from 70 to 90%, let's say, then it is a warning for us. We need to be aware, or we can understand that our CPU is struggling to cater the request. And if the CPU utilization goes 100%, then we have to understand that it is a danger situation. So we need to do something about it, right? So it shows like, basically CPU metric will show us that how busy your server brain is. And moving on to the next topic, first CPU is done. So this is how we, check, like if it is 0 to 50%, it's safe, 70 to 90%, it's a warning for us. And then if it is, exhausted 100%, that means a danger, right? Our application or our server may crash. Moving down to the second most important parameter is like RAM. So RAM is basically random access memory. So if RAM is full, the system crashes or you get an error like out of memory kill. This is one of the most common kind of errors that we get. So out of memory. So here what it generally means is like, let's say if memory is full, it is very likely that application gets application gets killed. Simple, right? So this is where out of memory error happens at the RAM. So there is an issue with the RAM. So you don't have any um, your RAM is full, your memory is full. Moving down to the third most important parameter is your network. So for example, network, what does this mean? So for example, if there is a high traffic, you are likely to have slower responses. If there is a high traffic, you're likely to have slower responses. So your server can't send data fast enough. So when there is large number of, for example, let's say this is your server over here, right? And server is handling 10 requests, 10 requests, right? Now suddenly 10 requests, if it is getting catered, it is working fine. But let's say if suddenly it goes to 100 requests, that means your responses will be slower because the previous request has not be catered, and all of the requests, all of the the request which is in queue will take time to reach to the server and then get a response and then to get back. So that is what we mean by whenever there is high traffic, your server may respond slowly. Next is disk input output. So basically, whenever if the disk input output writing is slow, for example, if there is a slow disk, then you will be witnessing a delayed processing, because each and every request that we make to a server, it happens to write something, read something or write something. It maybe reading is like fetching some data and getting back to you, or writing means you have put up an entry and that needs to be put inside that disk also. So that is what I mean by over here, that if the disks are slow, that means it is slow read or write. Read or write operations will be very much slow. And then in that case, apps may take longer to respond. Again, one of the factor why server could crash. And one more important is like load average. So what does load average mean over here? So load average simply says that how many processes are competing for CPU. What does it mean? How many process are competing for CPU, because each and every process needs to reach to the server, and who does all that management? The CPU, right? So higher the load, system gets overloaded. So more load, more request, higher load, the system gets overloaded. So what are the key metrics that we need to check the server performance? So first is your CPU. So CPU, you have got a safe mark over here. Like if it is 0 to 50%, it is safe. 70 to 90%, we need to look into the server because it's a warning sign. We can understand that our server is struggling to process the request, and if it has reached 100%, boom, it's a danger. Then if it is RAM, so RAM means like if your memory is full, application gets killed. So you will also, when you inspect, you will also find this very common error over here, which is that OOM kill, which is called as out of memory kill. Third is network. So if there are more requests coming down, then the response is going to be slower. Why? Because the previous response is supposed to be catered before catering a new response. So high traffic, slower response. And disk input output. So each and every operation, each and every request will be reading or writing some of the data on the disk. So if your disks get slowed, then also application would take longer to respond. And finally, it is load average. That means how many processes are requesting the CPU to get their task catered. So how to check these? So these all four or five parameters, like after configuring your server that we have seen. But how do we check it on the system? So there are certain tools to it. So what are the tools? So for example, these are the tools, and these are basically the commands. So for example, if you type top command, what does it shows? It shows real time CPU, how much it has been utilized. It also shows you memory and the running process, what all process are running, right? So using top command, we can get this information. Then there is also a command called as htop. So htop is nothing different. It is basically a colorful and a easier version of top. So it is colorful and easier version of top command. It also shows CPU memory and running processes. Third is free hyphen M. So free hyphen M shows that how much RAM is being used, how much is free and how much is available. So this shows RAM, how much is free, how much is used, and how much is available. Because we also, if we don't have a close look onto the RAM, then our application would also not be accessible with an error called as double OM, which is out of memory. And And one more is the netstat. So netstat is a very famous command. I think everybody who is working on Linux servers, they happen to use it, right? So what does it shows? It shows active network connections and ports. What does it shows? Active network connections and ports. Ports are nothing but the logical openings. For example, if this is your server, this is a logical port, let it be 8000. So how many users or this application is listening on? This application is listening on port 8000. Then this application may also be listening on, let's say, some other application may also be listening on some other port, maybe 9000. So this particular command says that how many active connections are there, and what ports are they using. So all these commands, I'll be using in the part 2. So part 2 of this video is going to be entire demonstration of, what all we are studying over here. We will have a total deep understanding on why server crashes under load, and how do we simulate a crash kind of a situation over there, and we'll try to debug all these kind of things. Practical implementation is going to be in the part 2. So part 2 is going to be all about practical implementation. So I'll be posting the link of part 2 in the comments as well, right? Okay. Now we'll move down to some of the questions, basic questions, like why do servers crash? We all happen to understand, like, because whenever we are configuring a server to host our application, we would never want our application to crash or server to crash. But why do they crash? So there could be certain reasons, some of the basic reason. First is the CPU exhaustion. So what does this mean? CPU exhaustion over here, it means that too many requests. What does this mean? Too many requests. So the server can't keep up. So there are too many requests and the server cannot process it. That's why this your server crashes. And this is CPU exhaustion is one of the reason why the server crash. Second is memory exhaustion. Again, you guessed it right. This is all because of RAM. So application consumes all the RAM and system kills it. What does happen over here? So your application has consumed all the RAM, and then your system, since there is no RAM available, no memory available, then system is going to kill it. Next could be, too many connections. What does too many connections means? That server hits a connection limit and rejects user. So for example, this is your server and it has got a capacity of 100, and 100 users are currently accessing the particular application. So if it is 101, so just a second, maybe. So this is a issue of the internet. So basically what I was saying, like for example, too many connection. Let's say your server is having a, bandwidth of 100 connections, right? And 100 connections has already been exhausted. So what will happen in that case? In that case, your server or your system will not accept more connections. And in that case, it is going to reject users, right? So that is one of the problem that we can face. Apart from that, there is also application bugs. So application bugs, what could be the issue of the application bug? For example, there is leaks, or there are infinite loops, application centric issues. So with that could be one of the reason why your server also crash. Fifth reason, if you are moving on to the fifth reason, it is like traffic spike. So for example, as I said in the first example, so let's say your system is confined or designed to accept 100 requests at max, and suddenly 10,000 users come in. So traffic spiked, right? And then the load also increased. So in that case also your server may crash. And one of the last reason that I could see over here is dependency failure. So what is dependency failure over here? So dependency failure is basically, database or external APIs that slows down, or maybe, that, create some of the other kind of issues. So basically the application, whatever it is hosted, is also dependent on some of the other different microservices, or maybe application, or maybe database to communicate, right? For example, you are logging into your application. Uh, and then whenever you are putting your username and password, so that username and password has to be validated from the database. Now, if the database is not responding, then your request is taking longer to complete. And in that case also, the server crashes, right? Now, what are some of the common error codes that the developer must know? So what are the common errors that we see? So first error that we can see is called as internal server error. So what is this internal server error? So internal server error, okay, I think there is an issue with the internet. Let me try to get it back. Okay, I think we are connected. Let us see if we are back. Yes, so there was a problem with the internet itself, and that's why it went down, but not a problem. Okay, perfect. So everything is here intact, and I hope, let me just zoom it up for you. Okay, perfect. I think we have seen all this, and too many requests. Okay, now let us go to common errors. So what are the common errors that we see? For example, let's say you have created your application, and your application, the users are trying to access the application, and suddenly they're getting an error as called as 500 internal server error. So whenever there is a 500 internal server error, it is very likely due to your application issue. So what kind of issue? So here we need to directly go and check that there is something wrong with the application. So what we can say, that something broke inside the application. Something broke inside the application. It could be, what could be the reason? It could be a bad code, some of the other problem. Then it could be a bug inside, or the application itself is crashing, or maybe some of the other dependencies are not working fine in the production. So that could be some of the issues why you see the first error, that is called as internal server error. Second error, what we very generically see out there, is called as 503 service unavailable. So this directly means your server is overloaded. So what does this mean? Server server overloaded. So it means that your server has taken too many requests, and it cannot take no more requests. So this is your application. Your limit was 100. It has already reached 100 users, and if it is 101 user, then he will see an error called as 503, service temporarily unavailable, right? Now, one more error, the third error that we are going to see very common, it is called as 504 gateway timeout. So it is upstream service slow. What does this mean? So your backend service. So for example, as I said, that your application is also dependent on some of the other service. So here what this means, that, for example, let's say your backend service, which could be like your database or maybe some of the other API, is too slow to respond. So let's say if there is a user over here, and user is authenticating, or logging into the application. So here he is putting his username, and it is putting his password. So it is not directly that you have just put in the username and the password, then you log in. It has to be validated. So for validating, this server will go So for validating, this server will go to the database, and from the database, it will check, okay, this is the user, okay, fine. This is the password, okay, fine. Then it is validating over here, and then you happen to log in. But what if this particular connection is slowed down? So in that case, when this particular connection is not able to establish, so in that case, we see an error called as 504 gateway timeout. And the fourth error that we can see over here is connection refused. So connection refused is, again, that is server is not accepting connections. Server is not accepting connections. So this simply means that your server is overloaded with the request and it is not accepting more connections. Usually it is because it is down. So what are the reasons why server is not accepting connections? So one reason is like the server is down or server is overloaded. So these are the possible reasons why we see this error, that is error connection refused. And one more error that we see, the last error that we are going to discuss is called as not enough memory to open this particular application. So this is basically a OOM killed. What do we mean by OOM kill? That I explained just above. It means that out of memory killed. So system killed your app due to RAM shortage. For example, if this is your application and this application has exhausted all the RAM that is required for its functioning and the RAM is 0% now or the RAM is 0 now. So then the system will kill your application. So in that case, we will see not enough memory to open this page. So I'm very much sure that all of you, whenever you are, opening or some or the other application, you must have come across these kind of errors. So these are the very common and generic errors that we have discussed. So what are the 5 errors that we have discussed? First is internal server error. Internal server error clearly said there is something issue with your application. So you need to check the application first. Second, if you are getting a 503 service temporarily unavailable, so this means that your server is overloaded and it is not taking much requests. So if the capacity is 100, 100 is already exhausted, 100 users are already logged into the server and 101. So 101 number user will not be able to access the application and he will get an error called as 503 service temporarily unavailable. Third is your 504 gateway timeout. So it says that your backend service, so your application which is hosted on the server has got other dependencies, just like maybe an API or maybe backend or let's say there is a three-tier architecture. For example, this is your front end, this is your backend, and the backend further is connected to your database. So if either of them is too slow to respond, then in that case you get an error called as 504 gateway timeout. Fourth error is error connection refuse. So again, could be reason is either your server is down or your server is overloaded. And the fifth one is your if your application has exhausted all the RAM that has been given towards its functioning, then the system will kill the application. So in that case, you will get not enough memory to open this page, or basically it is a OOM killed. That is out of memory killed. So these are the possible errors that we can see. Now, how to debug those errors, right? So if there are errors and if once you have created the application, deployed it on a server, and you're facing one or the other kind of errors that we have just discussed, so you would also want to debug it, right? So how can we debug these errors? So first option is like we can check logs. So we can check the application logs, because whenever you have created the application, you have also created the logs. Like each and every process, each and every timestamp would be logging in there. So we can check that what is the error over there. And plus at the same time, we can also check the system logs. Everything is what we are going to cover in the demonstration, the part 2 of this video. Now checking the metrics. So checking the metrics is like how much CPU is utilized, how much RAM is utilized, is there any free space, is there any kind of port that is refusing the connection, or is there any network issue? So this is what we can check and identify. Is there any problem with the metrics over here? Then we can also check the pattern. So pattern is like what? For example, if there is continuous load means, for example, we can see that in the weekends the load to this particular website or the number of requests towards this particular website increases exponentially. So what we can do the auto scaling, or we can increase the server parameters over here, so that all the request gets catered. And in this case we should also be prepared about the sudden spikes. So if it is only on the weekend, then it is predictable, but if it is a sudden spike, we should also be prepared for that. So it is sudden spikes. Now again, we have to check the dependencies. As I said, that if it is a three-tier architecture application, this is your front end. So user logs into the front end, then front end has all the logic inside the back end, and the back end has got a database in which the read or write operations are there. So if any of these dependencies are not establishing proper connection, then again we could see an error. So we can check that also. So either it could be a DB related issue, or maybe you have used Redis in there, that is that is again could be creating an issue, or it is an API related issue. That is all we can check. Now, one more thing is like we can reproduce the issue. So what we can do, we can simulate. So for example, you have got multiple environments. Let's say this is your prod environment. So prod, you have got a error, whatever error it is, right? And then you have got a lower environment. Let's say it is a dev environment. So from development, you do the development and then you push the code to prod. So you can simulate the exact issue using the load test and check like how does your application performs in the load environment, and then when you are reproducing and when you have replicated the issue, you can apply a fix and then you can push it back to the production. So this is how you can do. And yes, after doing all that, you can apply the fix, right? So this is how you scale, optimize, and patch bugs, right? So this was the theory behind why servers crash. And we happen to have a detailed discussion on a lot of topics. So what did we discuss today? So we discuss a simple analogy like why server crashes. Then we understood the analogy like how can we compare a restaurant to our server and the applications over here, right? And then we understood like the equivalent. For example, customer is equivalent to users, orders are equivalent to requests, and likewise everything. Then we also understood like how to choose a server whenever we are working on an application and we are about to choose a server. Then how should we choose a server? What all parameters should we consider is something that we have covered over here, like estimate users, type of application, what kind of request it is going to handle, how we are going to do peak load planning. Apart from that, we are also going to check server performance. Like for example, if our application is deployed, we have chosen the server, application is deployed. Now we have to check that what is the status of CPU, RAM, how is the traffic, is it a high traffic, then there is a slower response, then disk input output operation, how is it, and we also have to check about the load. Post that, we also have certain tools which we can use to check all these all these metrics that I'll be showing in the practical implementation, the second part of this video. Apart from that, we also understood some of the reasons why servers crash. There is CPU exhaustion, memory exhaustion, too many connections, then there could be problem with the application, sudden traffic spikes, then there are dependency failures. And post that, we also understood some of the common errors that we see. So it is a internal server error, then service temporarily unavailable, gateway timeout, error connection refused, and not enough memory. And then we also understood how to debug it, right? So in my next video or in the part two, I'll be showing you an explosive hands-on demo. Right? So we'll overload a server, monitor it, break it, and even crash Docker container live. So I would not want you to miss the part two. So part two will be coming very soon. And thank you for watching the video. Keep supporting. Till then, bye bye.